Take 45. Wow. Alright. Hello, my name is Anthony David Perez. You guys are my students for the next few minutes, and I shall be your teacher for the next few minutes. Now, as your teacher, my first assignment for you guys will be to bear with me and my croaked voice. Although it might not seem that bad right now, it might get worse throughout this video, and I might even cough a few times, so if that does happen, I am very sorry. I can't control my body. I'm currently getting better from being sick, so if anything happens, I am very sorry, and I'll try to keep it at a minimum. Now, to start off with the lesson, I like to go a little back in time when we were in Algebra 1. We had the blue book, and it was pretty fine and dandy. It was pretty simple since we were dealing with lines, and we were dealing with their intercepts, with their with plotting them, making their little points and connecting the dots, and it wasn't that crazy. And we most importantly had to work with their slopes. Now, in our current math lesson today, we will be learning on how to find the slope of more lines. Now, yeah, sure, that's not all that crazy, you might say, but believe me, it's a little bit more complicated only because these lines are not straight, they are curves. Now, with this being said, there is multiple slopes, and it's constantly changing as you go throughout the line. With that being said, how do we find the slope? Because it's a little weird, and especially with undefined points, it shall be a little bit weird to explain, but we shall go along with the lesson, and we'll do this. We'll get through this together. So here in our more advanced line, very slightly more advanced line, you'll notice that I made 2 points, point 1 and point 2. First point having the coordinates of x and f of x, and the second one having x plus h and f of x plus h. Now you must be thinking, what does the h mean? What is f of x plus h? And you might be freaking out, but I assure you it's nothing bad. H is only signifying the distance in between the 2 points, and later on you'll be using what we call the difference quotient, our good friend down here. Now, what we want to end up using these 2 random points that we have no idea what their values might be for is to find our slope. As you guys know, yes, this again, y2 minus y1 over x2 minus x1 will help us find the slope of any line. So we obviously need the values of 2 points in a line, in the same line. But since we don't know what these values are, we know them as x and the output of x, which would be f of x, and then x plus h, since there is a distance, it's x plus h, and then the function of x plus h, or the output. So, going back to this right here, since we don't actually have numbers to go into here, it'll look a little more like this, since we have, h's and x's and apparently f's too. The difference quotient, this is what the difference quotient really looks like. It doesn't look like this all the way, only because if you notice the h is alone and it doesn't have the 2 x's with it. That's only because if you were to try to simplify this as much as possible, the farthest you can go is eliminating the 2 x's, since they are reciprocals of each other. They can cancel out, and you would just leave h alone. And when you start thinking about this, he starts saying, "Hey, Mr. Perez, it's impossible for h uh, be to be the denominator at the moment, and if you're farther ahead, you'll know why. But otherwise, let me go on a little further, and I'll explain why we want to eventually get rid of this denominator, and a basic rule that we all know. So we're gonna zoom in into that previous line. And if you notice here, I zoomed in by 10,000. It's probably not 10,000, but I just like 10,000 because it has a lot of zeros. It's probably somewhere big numbers, but I don't know how much zoom this is in, so I just want to say 10,000. Anyways, we zoomed into this little curve of the graph, and as you can tell here, this is our certain slope line, and as you notice, it shares one point with the curve, meaning that it only skims on that tiny part and never touches again. And that's because if it were to be in any other point, it would have to be a different line, a different slope, in other words. And if you notice, I didn't put any other point, and this is because they're both on the same point. Now, you might be thinking, what? That's weird, that's strange. Now, think about it. If we are trying to find a slope, it'll be a lot simpler if we can get them to be as close as possible, so the distance in between them would have to be 0. Therefore, h would be 0 here in the difference quotient. Now, if you notice, h being the denominator, we do not want 0 to be the denominator, because just like Mr. Nuno's shirt implies, friends do not allow friends to divide by 0. Any computer will go boom boom, and we do not want chaos because we do not want to be performing the impossible in math. So, let me be your friend and make sure you do not divide by 0. So, this denominator cannot be 0, and therefore we are going to try to make sure that this is no longer the denominator. We're going to make sure that's out of the way so that we can make h 0. I know it's kind of going around the rules, but I'm the math teacher, you're the student, deal with it. Just deal with my logic. So, if we were to go into this example question where f of x would be x squared, since a parabola, if you were to try to map that, a parabola is a basic curve that most people are not too fond of, but I personally am, so I will work with that x squared. And here's our friendly difference quotient. We plug in these numbers and we get x plus h in parentheses squared minus x squared over h. Why would I have this here? Because we're trying to get the function of x, and since this is this was the function of x plus h, instead of having x squared, we had x plus h squared, because we still have to include that h in there, and then minus f of x. Since f of x is in fact x squared, we just decided to subtract this by x squared, or minus it. I don't like saying minus, but I don't know in what context to say this, or how to say this, like grammatically correct. And then we put that over h, because h never changes, because there's nothing in here that implies that h ever changed. Okay, so we try to simplify this, and we have this being x squared plus 2xh plus h squared minus x squared over h. Yeah, pretty big. We want to simplify that. So on to the next step. We cancel out the two x's, since there's a negative and a positive, and we just want to make this a lot simpler. So here's a simplified version of it, which is 2xh plus h squared over h. That's a lot of h's. What can you tell out of that? We can factor out some of these h's from the top, from the numerator, because we don't want to deal with so many h's. So we factor out the h here. And so out of the parentheses, we have that h that was factored out, and inside the parentheses is 2x plus h, and then all of that's over h. On to the next step. We cancel out the h's that are from the numerator and the denominator, and this is helping us because that's what essentially we want to do. We want to simplify this in a way where we can take out that h so that it won't be a pest to us anymore, and that leaves us with this equation, this problem, 2x plus h. And now that h is no longer part of being the denominator, we can allow it to be 0. So at that moment, we let h become 0. And since h becomes 0, there's no point in keeping it there. You can just bring it down to 2x. Now, this is not the slope for that particular point. This is what we would call the derivative. Now, that would mean change over time. And with that, we are able to calculate like the rate of change. So in our parabola, whatever the last value of x would be, you would multiply that by 2 for the next value of x, and then on and on. So it's a constant rate, like a constant change of rate. So yeah, so that would conclude our lesson. I hope you guys kind of more or less understand why all this mumbo jumbo is here, and hopefully you guys will do better on your tests. And I hopefully made it a little bit easier to find the slope, only because with this derivative, you later on gonna see that plugging that in to your original x squared will help you find the slope of that particular point, and that would be the same case for any other point in the line. But you know, you can't really do that considering that we don't have exact values for these points. But it was just an example of what you would do. So you guys, you know, have it easy. You guys do well on your tests, and if you guys end up doing amazing due to my video, make sure to write it down onto, you know, the paper. It's like thanks to Anthony Perez, you know, little credit here and there. Anyways, thank you guys for listening. Have a good night.